afternoon, majors. We are going over Unit 7, Day 3, Trigonometry A, meaning we're going to do Part 1 today, and then next class we're going to do Part 2. So today we're going to focus about what is the trig ratio, and then try to solve a couple of problems related to that. And then next class we will do the same thing but related more with the angles. So what is trigonometry? It came from a Greek term meaning triangle. It's a combination of two Greek terms. One is triangle, the other one is measure. So triangle measure is what we're talking about. When we're talking about trigonometric ratio, it's a ratio of the length of two sides of a right triangle. Okay, so it's important to know that we can only use trig ratio if the triangle is a right triangle. The three most common trig ratio, or the three that we're going to be using in this class, is sine, cosine, and tangent. Okay, each one of them represent a different ratio, its own ratio. Sine gets abbreviated as sin, but you don't read it as sin. You read it as sine. Okay, every time you see this, this is sine of A. Sine of A represent a leg opposite to A over the hypotenuse. So every time we have a right triangle, the side opposite to the 90-degree is your hypotenuse. That part doesn't change. But the opposite side and then the adjacent side changes depending on what angle you're looking at. Okay? So remember, hypotenuse does not change. It doesn't matter what sine of what you're asking, but the opposite side and the adjacent side always change depending on the degree or the angle you're looking at. So for the first part, this is all as talking about sine of A or cosine of A or tangent of A. So we always gonna circle the angle we're representing. So which side is going to be opposite to A? So the side across from it, in this case BC, is the opposite side. Okay? And then which side is going to be the adjacent side? Adjacent meaning next to. So this becomes the adjacent side. And then the last one is the hypotenuse. The hypotenuse is always the same. It's also the adjacent side, but since it's opposite to the 90-degree, this side, which is AB, stays to be the hypotenuse. So when they ask you to write sine of an angle, you're writing the ratio of the side. So the measure of leg opposite to A, in this case, the opposite leg is BC, right? Over the hypotenuse is AB. That is the ratio. Cosine is the measure of a leg adjacent to A. So adjacent side is AC, right? Over the hypotenuse is the same, which is AB. Okay? And then tangent, short, you call it tan, is the measure of opposite to A. Remember, opposite is the yellow one, which is BC, over the adjacent, which is the red one, which is BC. Okay? That's what you guys have to remember. One thing new for the new SOL, this part would be given to you in your formula sheet as this. So they would say sine of theta. Theta is the angle here. Sine is opposite over hypotenuse. So opposite side is going to be the yellow side, right? For the theta, right? And the adjacent side is going to be the one in red, which is next to, and then the hypotenuse is going to be your green. Okay, so when the question is asking you to write the ratio of sine of theta, O, right, this is A, and this is H. O, A, O, and then Z is going to be your H. X is opposite, Z is the hypotenuse, Y is the adjacent, based on theta. Okay, so when the question is asking you what is sine, sine is opposite over hypotenuse, O over H is going to be X over Z, right? Kind of hard to write Z. Cos is adjacent, right here, adjacent over hypotenuse. Adjacent is Y, and the hypotenuse is Z. Tangent is opposite over adjacent, which is Y. So that's what we have to do. Sine is X over Z, cos is Y over Z, tan is X over Y. One thing you should notice is sine and cosine would have the hypotenuse as a denominator. Tangent would not have a hypotenuse. Okay, so you guys have to find a different way to memorize this trig ratio, or this would be given, and then you should be able to use that as we go through to solve the problem. So now the question is asking you find A, sine of A, cosine of A, and tangent of A. So since we are talking about sine of A, I'm starting from A, and then every time I circle this, and then I said, okay, from A, the opposite is going to be this side, opposite, right? 12. And the hypotenuse, no, the adjacent is going to be 5. So this is 5 is the adjacent side. And then the hypotenuse is going to be the 13. So this part doesn't change, right? This part doesn't change depending on either I'm doing sine A or sine B. If I'm looking at from B, B is going to be here. So, but the hypotenuse doesn't change, but the opposite side for B is different, okay? So I'll do sine A, cos A, and tan A, and you guys have to do sine B, cos B, tan B. So sine is OH, I'm sorry. So the ratio is going to be 12 over 13. Cos is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so that's what, so find the indicated trig ratio as a fraction, that's what we did, as a decimal, and round it to the nearest decimal. So what we're going to do is, what is it going to be rounded to decimal point? So I don't have a calculator on me, so I'm not going to do this part, but you guys can do it, it's not a problem. And then the next thing I want you to do is sine of B. So one thing I'm going to give you is this two p's are going to be different, because now I'm looking at from point of B, right? Now my point of B, looking at it, is from B. So what is opposite to B? So now my opposite is going to be 5. Now my adjacent is going to be 12. So that's the one I'm going to use to write down the ratio here. So in summary, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tangent is opposite over adjacent. There are different way to memorize this. I've heard of some old horse came a hopping through our alley. So you just use the first letter of the trig ratio and try to memorize it. But you guys find out, a way to help you memorize this. And then we'll go over it again next class, okay? So next page is, here's to help you. I'm sure if you have older sibling, you probably have heard of SOHCAHTOA. And sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent. You use scientific calculators to change the sum of the trig ratios, but one thing you guys have to make sure is the degree, the mode needs to be in degree form, okay? So I'll show you how to change it. For example, finding cos of 41, we gotta press cos first, and then we have to type in 41. So I want you guys to practice on TI calculator. I'm sure your computer has it, and I'll show you how we're gonna get to that. So in your, if not, just ask me in class, and I will do it in class for you on your calculator. Alright, so now I just pull in my TI 84 calculator, If you have it on your um, in your laptop, you guys can also pull it, but I'm going to show you. If not, we'll practice it in class. What I was talking about here, where it talks about make sure it's in a degree mode. The default setting for the TI-84 is in radian form. So how would you know where to go? The first thing you need to do is click on the mode. Okay, so when you click on the mode, you can see that it's normal, scientific, and English is what the top is. This is the floating, how many decimals you want the answers to be. That's the set. But the third one says radian and degree. That is the one I need you guys to go to. So you press it 3 times. So the default is in radian, but I need it to be in degree form. The cursor needs to be in degree form. And then when you press enter, it would like blink on it, and it just, that's where it's going to be. So when I do second quit, it'll take it away. If you want to check, see if you, when you click mode again, see how this is in degree form. That is what you want it to be. Okay, that's where we are going to be doing it. So now we're going to do, once we get it into degree form, I want to know what is cos. So when you press cos, it gives you that of 41. Okay, cos 41, you press enter, it gives you 0.75475. Okay, one thing I can I want you to understand is cos of the degree, which is this one. So you always write it as this, cos of 41. If you're using a phone, you usually put the number in, and then you press the sine, cosine, or tangent to get to this one. But each phone is different. Android does it different than iPhone. So if you guys, I wouldn't recommend it, but if you want me to show you which way your phone works, we will talk about it in class. All right? So what I want you guys to do right now is take this sine 43. What is sine? So you put sine, and then you put 43. Press enter, enter, and write down the answer. Okay, what is cos of 84? What is tangent of 21? Rounded to the nearest, what does this say here? Nearest 10,000. Okay, so rounded to the nearest 10,000. You don't need to write everything down. Okay, all right, so now another thing we need to do is, okay, what if I have the decimal point but not the number itself? Okay, I don't know what the degree is. Here I know the degree, but I don't know the decimal, right? That's what we have. Okay, so what if I have, so in this case, I'm going to pull this back up again so that you guys can kind of see it. I don't know, viewing, if I can make it the size a little bit bigger. Um, so we can try. See how I got cos 41 to be 0.7547006. What if I only have this part, not the 41 part? So what I need to do is you press second cos, and then you enter this number to your best, to the 10,000 or whatever. I'm going to put it for everything, 0.74770. I'm pressing. Okay, let's jump in. 0.9595802, right? That's the number that I can see. Okay, so I put this number into the inverse function. Inverse is you just press second cos. Let's see the top part. And then when I press enter, it should give me the degree, which is 41, right? So we found sine 43 to be this, right? What if I didn't know what sine 43 was? So you can do second sine, which is the inverse function, sine, and then if you put this in, 0.6819998, and for example, I only want to put it this far. It will not give me 43, but something close to 43. See how it is? 42.9999. But if I put the whole thing in, I'll get the angle to be 43. So that is what we do when I don't have the Like when I don't know what the angle is, you do the inverse function. So that's what this part is talking about. So if you have your calculator, press second tan, put this in. What is A? Press second cos, put this in, and write what number it is. So the last thing we're going to do for this section is state the trig ratio. Is it sine? Is it cos? Is it tan? That correspond to this given angle. So they want you to look at it from point of view of Q, right? So I'm going to do it from Q. 3, so from Q, so these two are for Q. This is the opposite side, this is the adjacent side, and this is the hypotenuse, right? I'll write it down. Which trig ratio has 3 over 4? OA, right? That's what I have. This is OA. So if you look into your trig, OA is what? Good job. Tangent. Okay. Which trig ratio has 4 over 5? 4 over 5. 4 is the adjacent side. 5 is the hypotenuse. What is AH? That is cos. Okay, so I want you guys to do this too, but now your point of view gonna change. Now you're looking at it from P, which this becomes the O and this becomes the A for P. So we're not looking at it. So when it says 4 over 5, I'm looking at OH, right? What is that? 4/3, I'm looking at it OA. What is that? Okay, so just do those two. All right, so I'm going to try to solve one or two of the problem. So this is where it actually makes, okay, then how do you solve an equation, or how do you solve for x? Okay, so the first thing you guys going to do is you're going to circle the given angle, and then based on the angle, you're going to label what is given. So what is given is the opposite side, and then hypotenuse is what you're looking for. So that's what you always do. So that every time I have a trig ratio, I circle the side, no, the angle, I'm sorry. Based on the angle, I'm going to label it. Okay, this is 27. This is the opposite side, and this is the adjacent side. 52, I'm going to label. This is the adjacent side, and this is the hypotenuse. All right, so now I label it, right? So now, which trig ratio has sorry guys, which trig ratio has OH? Now this is what I label here is, let me move it a little bit higher. This trig has OA. This one has AH. I'm looking for one of them, or so this is what I got, right? OH. So what is OH? Sine. Very good. So you're going to put sine of 43. It is opposite over hypotenuse. Okay. This one is OA. OA is what? Tangent. Tangent of 27 is opposite, which is 5.8 over x. Third one is AH, which is cos of the degree, 52, adjacent over hypotenuse. Okay, then now we have a perfect, not a perfect, but I have a ratio. Okay, then you're going to cross multiply. So I can maybe do one of them because I don't want to extend it more than, but you guys can continue to do it. So when I cross multiply, this is what I get, right? So I get 7 equals y sine 43. All right, so I have to divide both sides by sine 43, sine 43. So 7 divided by sine 43 equals, so this cancel out, equals to y. So what I'm going to do is pull my calculator out, and let's clear this out. And then I'm going to go alpha y equals my fraction, and then I'm going to put 7 on the top, at the bottom, I'm going to put sine of 43. Okay, and you press enter. 10.26. 10, y is 10.26. Alright, guys, now you guys do this two problem. Okay? Alright, it's not more than 20 minutes. Alright, have a good afternoon or morning. I don't know what time you guys are watching this. But I'll see you in class to talk about and to do more problem.